Hey guys, it's Danny here from Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals with some common reactions involving organic compounds. We're given 4 different reactions involving the organic compounds labeled A to E, and the first 3 reactions are sequential, starting with compound A and producing at last compound D, for which we're given the structural formula. So the first question asks us to name the general type of reaction for reaction 1 and reaction 3. So first we need to determine what substances are reacting, and then we can determine the kind of reaction that's taking place. So let's take a look at the first one. An organic molecule A reacts with bromine in the presence of UV light to produce another organic molecule B and hydrogen bromide. Looking at the difference between the reactants and the products, we can see that we go from 2 bromine atoms to a bromine atom and a hydrogen atom in the hydrogen bromide. So this hydrogen could only have come from A, and we can conclude that a hydrogen is removed from A and then replaced with a bromine atom. This, in addition to the UV light, is characteristic of a substitution reaction involving a halogen, and it results in a haloalkane. So we can now say that A is an alkane, and that reacts with a halogen to produce B, which is a haloalkane. Okay, and then in the second reaction, this organic molecule B, which is a haloalkane, reacts with concentrated alcoholic potassium hydroxide to produce organic compound C, potassium bromide, and water. So once again, we look at the difference between the products and the reactants, and we can see that the potassium hydroxide, the KOH, has broken into a potassium ion, which has then formed potassium bromide with the bromine from compound B, and also the hydroxide ion, which has formed water with another hydrogen atom from compound B. So that means that a hydrogen and a bromine have been removed from this haloalkane, and that is characteristic of an elimination reaction resulting in the formation of an alkene. So C is an alkene with a double bond between 2 carbon atoms somewhere. In the third reaction, organic compound C reacts with water in the presence of dilute phosphoric acid to produce compound D, which is an alcohol. So we've already determined that compound C is an alkene, and this third reaction is characteristic of an addition reaction where the double bond in the alkene is broken and then the water takes its place to form an alcohol. So it breaks up into hydroxide and hydrogen and then forms the alcohol. So we've determined the general types of the reactions 1 and 3, so you can go back and make sure. Reaction 1 is a substitution reaction, and then reaction 3 is an addition reaction. So D is then an alcohol. Okay, so moving on. The second question asks us to name the specific type of reaction for reactions 2 and 3. So once again, you can go back and confirm, but we determined that reaction 2 is an elimination reaction in which a halogen and a hydrogen are removed from product B, and this process is called dehalohydrogenation. Okay, so long word, dehalohydrogenation. And then we determined reaction 3 to be an addition reaction where an alcohol and a hydrogen are added to an alkene where the double bond is broken, and this type of reaction is called hydration. So now we're not concerned with the general types of reactions, but rather the specific types, which refer to the exact substance that is added or substituted or replaced in a certain molecule. Okay, so dehalohydrogenation and hydration are the names of the specific reactions for reaction 2 and reaction 3. Okay, so then third question asks us to write down the IUPAC name of compound D. So we're given the structural formula. It has 7 carbon atoms and an alcohol on the second carbon in the chain. So recall that the numbering of carbons is done so that the functional group has the lowest possible number assigned. So that means that we start the numbering from the left side of the molecule, and that means that the alcohol is attached to the second carbon in the chain. And there are 7 carbons, so we use the prefix hept, and this is heptane 2-ol, or 2-heptanol. Okay. And then the next question asks us to write the molecular formula for compounds A and E. So compound A is an alkane that undergoes reactions 1, 2, and 3 to finally produce D. Now remember, in the beginning we said that A is an alkane. You can go back and confirm that by looking at the different reactions that it goes through. And it has 7 carbons, since we know that no carbons are added or removed in reactions 1, 2, and 3. So if it produces product D, then A also has 7 carbon atoms. And we know the general formula for the alkanes, which is CnH2n plus 2. So we can find the molecular formula for the alkane with 7 carbons, and that is C7H16. So that is the molecular formula for substance A. And then let's look at reaction 4, so the reaction involving substance E. Compound A decomposes into C4H10, which is also an alkane, and that is along with compound E when subject to high temperatures in the presence of a catalyst. So that means that E is made up of the leftover carbon atoms and hydrogen, since nothing else is added to product A, it is just broken apart. And since the molecular formula of A is C7H16, that means that we can subtract C4H10 to find the molecular formula of E, and that gives us C3H6 as the molecular formula for substance E. Okay, and then the last 2 questions, 9.5 asks us to draw the structural formula of compound B. So we've determined that A is a haloalkane containing bromine, B is a haloalkane containing bromine, and from compound D, the alcohol is on the second carbon. So that means that a double bond was broken between either C1 and C2 or C2 and C3. And that means that in reaction 2, the hydrogen and bromine were eliminated from either C1, C2, or C3. So if you work backwards with this, you can find what the structural formula is for compound C, and then compound B, and also compound A. But we know that the bromine and the hydrogen were definitely eliminated from either C1, C2, or C3. So that's where we have to fill them in when we draw the structural formula for compound B. So we can draw our 7 carbon atoms. And then we surround them with the hydrogens as usual. And then on C1, C2, or C3, we just have to add in the hydrogen and the bromine. So I'm going to choose carbon 1 and carbon 2 for adding the hydrogen and bromine, and then the rest of them are all hydrogen atoms. But you can also choose to put the bromine on the first carbon atom or on the third carbon atom. Okay, so those are equally as valid, but you just need to be consistent through all of your questions. If you choose to put them on the first or the third one, then you need to be consistent with where the bonds are being broken and where you're replacing or adding your different substances in these reactions. As we'll see now, the next question asks us to draw the structural formula of compound C. So since I put the bromine on the second carbon in the chain, when I remove that bromine in the second reaction, the elimination reaction to form the alkene, I need to remove the bromine and the hydrogen from that second carbon as well. So now to form the alkene, I can draw C, and then the double bond between C1 and C2 where the bromine and the hydrogen were removed, and then add in the other carbons and hydrogens. Okay, so those are just the normal hydrogens, the hydrogen bonds as always. Okay, and then if you had your bromine on another one of the carbon atoms, so if it was on 3 or 2, for example, then you would have had to put your double bond over here, in which case these would just have normal hydrogen, or this carbon would just have a normal hydrogen bond. So it all depends on where you chose to put your bromine atom in compound B, and then you just need to be consistent and put your double bond in the alkene there as well. Okay, so before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.